Okay, operating systems. I think you took the operating systems, right? Already.
Class?
Yeah. You didn't take CISC 421?
I don't think so.
Okay. So you've never taken operating systems
No.
at all? Oh, all right. What about Linux?
Oh, Linux.
You did, right? With me or someone else?
Someone.
Okay. Okay, what is the operating system? Operating system is it's very similar to database management systems. So operating systems is the package of gigantic the programs running together to manage your device. That is operating systems. On the other hand, the database systems, that is similar to operating systems, but it handles database only. Database is another big system. But we looked at database systems first, and now we'll start back a little bit to global size, the management system, which is operating systems. So operating system is a kind of a program that acts as an intermediary between user of the computer and the computer hardware. And now you can, the packages more and more developed and added to the operating systems. So you can do much about your entire system operations. This module, again, not even the operating systems for this 505 doesn't take one class. It's a lot shorter than one class. Rather, we spend more time on database systems. So we already spent 3 weeks of database systems, and then maybe 1/3 or 1/4 the operating systems. So operating system is a resource allocator. It manages all the resources from the storage to processing and also communications and controlling user access, securities, networks, everything. So it decides between conflicting requests for efficient and fair resource use. When I first learned the computer, one single user system and one single task is performed. Now multitasking, or sometimes we call multi-threading, in addition to multi-processing. Decades ago, we looked at only single processing. And the next step of that advancement of operating system or computer is multi-processing. After that, multitasking. After that, multi-threading. So on this slide, you may be able to see the difference among those. So operating system controls the user's process. What is a process, by the way, in your mind, Kevin? Process is nothing but a program. When you create one Python code, when you run it, it can be a process on the operating systems. They are talking about the same object, but naming differently. For developers, you simply code. There's one file, right? That is. But when you run it, the operating system take it, and it'll be one single process. If you open so many programs, web browser, even web browser, you open the multiple different tabs. Python code, the programs, maybe multi the programs runs at one time. Then each of those can be called a process. And there is a process ID. So your operating systems take care of each of those process ID. So they are the same thing, but they call it differently because if it is currently running on the operating systems, then that is called the process. If it is on your laptop, not being executed, then we call that a program file. Sometimes you can call job, print job. Job is the same thing, exact same thing as your process or your the code, your program file. What is a job? Job is from your operating systems. You have a subcontractor. I think you understand the subcontractor. To the printer. Hey, I'll give you a job. One printing job. So you can print it. That's a job, right? You clearly understand the job means in subcontract. Then, hey, give me a job. Then the contractor give you, is a contractor or contractee? Contractor. Or anyway, the boss give you a job. There's a job. Job process the program on your laptop. They are all the same object, same piece of objects. But depending upon where it is, we call it different. Okay? Don't be confused. This is a very, very important concept. Not many students can understand it. Okay, Bootstrap program. So the operating systems, like database management systems, consists of hundreds, thousands of programs available. Among massive programs, there is one unique program. We call it Bootstrap. What is a Bootstrap? Kevin, from your daily languages, what is a Bootstrap?
Study.
Right. Bootstrap is, have you wear the boots? I think you did, right? Cowboy boots? Do you ride the horse?
No.
Me never. But anyway, I know the cowboy boots. Cowboy boots is a long legs, right? It's very hard to take it, right? Take it on. So if you see the cowboy boots, the back tip on top, there is a small piece of the things that you can pull. So when you put your foot on the boots, then you can pull that boots to fit your legs. You see that's a small of those. Let me see your. Do you have small tip? Yeah, that is a bootstrap, right? That's a bootstrap. So that helps a lot, right? When you take some boots, particularly boots, boots needs to be fit tightly. Otherwise, what if boots moves by itself, and it's not the way that we wear the boots, right? So it should be tight in. To take the boots tight in and fit tightly to my legs, which means that is the right size. Therefore, without using any extra tools, it's very hard to pull into your legs. So there is a bootstrap. Exact same thing happens in the operating systems. If you look at next slide, usually your operating system stores here. This one is the disk. This is the storage. Okay, and your CPU runs here. The first thing that your laptop gets ready is to bring operating system up and running, right? Operating systems should be up. Where is the operating system located? Is the operating system, as I said, operating system is this gigantic big program. Does it always stays with the CPUs? Or does it stays on memory? No. It is always on the permanent storage, which is a disk. We call disk or storage. It is here. Once you have operating systems, then any programs that we can bring that up, how the programs can come. If you have your Python code here, say .py here, okay, this is your program. Then on this operating systems, on this memory, some of the instruction says, hey, if you click this, then I can bring that up here. It's a memory. So lots of instructions there. What is the instruction? There's nothing but the processor, operating systems processing. So when I click this, then my operating systems understand and bring that my Python code here. And my CPU, then I want to handle this guy, then bring that guy here, right? So that is the typical way that the operating systems can do. But here, the real problem is, what should we do? At the very first time, we do not have operating systems here. Who cares me? Who brings that operating systems into here? Therefore, all the instructions are ready to assist you, serve you. There's somebody needs to be there, right? It's called the bootstrap. So bootstrap stays here, not actually the storage, somewhere here. And without power, everything is dead, right? On your laptop. We need a power. If a power comes up, then we can do something. Before power comes up and operating systems loaded on the memory, therefore all the instructions are ready to serve you, who handles all those processes at the very first time? Memory is we call that RAM usually, right? This is a random access memory. All the data on this RAM will be gone when there is no power, right? And on your laptop and on your desktop, on the computer, there is also very small size of ROM. You know that, right? This is read-only memory, which means program is stored there. It's not going to be erased. That is only for the purpose of reading. On this ROM, there is a bootstrap, and this ROM has a battery. Its own battery. You know that laptop has its own batteries. Have you opened your laptop?
No.
Try, and there's a small batteries. If you take that out and push it back, what happens? You'll be in big trouble, right? If it causes damages to bootstrap, your laptop will not be booted. What that means is that, so from this battery, because battery is always there, I think the life of this battery may be almost 10 years. It lasts long. No one's really replaced the battery of your laptop while you are using it. There are 99.9% do not even know there is a batteries, right? So what this battery needs to do is to handle this ROM. Even the battery power comes up here and everything is ready. This battery, at the very first time, bring that bootstrap into this memory. Bootstrap this is kind of an instructor, but this is a special instructor. This needs to be done the very first time. This all the mission of this bootstrap needs to do is to bring operating systems into this memory. Like your bootstrap of your boots, bring your boots onto your legs. That's everything that bootstrap needs to do. After that, when you walk, who can help you? Bootstrap or your boots? Your boots, right? Your boots protect your feet and protect everything about you. Bootstrap doesn't do anything. Only one thing that bootstrap can do. The very first time that when you take your boots on. Same thing here. This bootstrap, because it has a battery, comes up here, the memory, and then the first thing that this guy needs to do is, because there is a operating systems, OS, gigantic programs here, that second, and then this gigantic systems needs to be up here. That is number 3. After that, this bootstrap does not need to stay here. After that, operating systems. Okay. That's what it is. Bootstrap program is loaded at the power up and reboots, typically stored on RAM or EPROM, ROM or EPROM. We call that firmware. It initializes all the aspects of the systems, which means load operating systems, kernels, and start execution. That is what the bootstrap needs to do. So bootstrap is a very, very important concept. Okay, we're talking about the memory here, right? This is a memory. So memory, what is a memory? Memory is a volatile the storage. It's not really storage. You cannot store anything because if there is no power, everything will go away. So the architecture of this memory is on top operating systems, and some jobs comes in. Then, as I said, this job is nothing but process. This is nothing but your program. So lots of those process can be loaded, and when one job is done, then this space is available for other jobs. Okay, so more and more comes. We call that swapping. Because job 1 is done, then that space is available. If all other spaces are now fully occupied by active jobs, then, but you click more programs to be active process here, then looking up here, the memory space, if there is any space available, then you swap. Bring that up and replace that once. So this is a memory. On top we have instructions and the data and some of the jobs programs loaded here. And then also we can think of this CPU here. CPU is a real, CPU means central process units. So the computation is performed here on this CPU. So if we have a multi-processing systems, then we have a multi-processor, right? One CPU, two CPUs, three CPUs, four CPUs. For each CPUs, we have a registers and cache. Like here, we have a CPUs, and it has a cache. What is a cache? Cache is kind of memory or kind of storage, but it sticks to this CPU. So when CPU needs, hey, give me the data, then if this CPU holds that data, then this CPU can solve that data very quickly. So what the CPU needs to do is, CPU understand the current thread of executions and bring the data to load near the CPU. So whenever CPU needs the data may be available in the cache memory. Therefore, data moving time, data transmission time can be reduced. Let's think of the processing time. CPU processing time is the fastest. Data transmission between CPU and memory relatively fast. What about data transmitting between hard disk drive and your memory? This is very slow, right? Sometimes you can hear when it reads the data. This so silent, although it heats up more, but very fast. Processing time here, CPU, really fast. So that is that. What is a multi-threading? Multi-threading is, this is a single thread. You have a single register and single stack and single memories, single CPUs. This is a single processor, single thread architecture. Thread is kind of, literally, it is a thread. It's somehow chain of the work. If you have a single processor multi-threads, then this is one CPU, but you can run multiple different programs, and that program runs as if there is one program running, although many other programs still runs. You know why? Because it has its own register, its own stack. Stack means there's nothing but this memory stack. Okay, so I don't need to say, hey, operating systems, give me the storage. A lot of the interactions here, but if we have a multi-threading, my program, me, as if I'm the only one, I can manage my memory, I can manage my registers, I can bring the data in. But these kind of things can run multiple different things. That is multi-threading. Okay. Having the multi-threading and multi-CPUs, we can now virtualizations. This is one single systems. If you have virtualizations like a cloud computings, given one hardware, we can have a multiple different virtual machines. Virtual machine 1, virtual machine 2, virtual machine 3, as if virtual machine 1 itself has its own hardware. Okay, but in this case, one hardware, but we have different virtual machines. One example is one laptop, you can run Windows systems, and also you can run Linux operating systems. Also, you can run Mac OS by partitioning your hardware. Hardware is not really partitioned. Up here, only whatever the resource here. Yeah, this part is partitioned. Three things here, so that you can have, oh, this is my kernel and my processor. This is my kernel, my process. Like we have, oh, this is my kernel, my process. There's only one systems. My operating systems, my hardware dedicated to my operating systems. In this case, my hardware can serve Linux and also Mac OS and Windows. All these things can be handled by this virtual machine manager. So given one hardware, you can install virtual machine manager. If you have that virtual machine manager, then you can set up multiple different, depending upon the capacity of your hardware. It needs a big memory size. It needs big storages. It needs multiple different controllers available. Okay, this is virtualization. Any questions so far? Okay, now their operating systems, can we do somehow on our Python? So Python, my code can handle the operating systems? Yes, you can, right? So if I bring terminal and Python, in order to use that operating systems, I need to import OS. And if I do OS name, then you can say POSIX and OS dot get GWD. What is my current working directory? What is the path expression up to this point? Then on top, users, and then JUN. So this Python runs the home directory of JUN. That's what I can see here, right? So can I see the list of the files on top of my home directory? Then you can say list dir. I'm doing this, list dir. Then you can see it has dot all history, dot, so music, and then some of the, let me bring one here.
You use Python in the terminal?
Huh?
So you're using Python in the terminal?
Correct, yeah. So I have here, this is JUN. It has a downloads and picture directory. So somewhere here, I believe downloads and picture directories. It has a desktop, which is, I want to make this alphabets. So JUN. What's the desktop? Desktop libraries. This guy doesn't show much. Why? I can bring up from another directory. For example, this is operating system. This is a Python, right? This is Python prompt. This is operating system prompt. So when I do ls, then I can see here application, then I should have some application here. I have desktop, library, So we have desktop,
C applications.
library. So this is the same as this. So you can see all of this. I'm not going to make a directory, rename, remove directories. This can be done on your operating systems. And the next, and then environment CPU counts. We see how many CPUs, so that you can see os dot CPU underscore count. 10 CPUs. I didn't know. Quite a lot. And then os dot get login. Who currently logged in this operating systems? Jae-yoon, which is me. So some of the information that you could do on the command line, either Windows command line or Linux command line, can be done on the Python. So within your Python program, if you want to handle your laptop itself, that is possible. Only if you import OS. Okay. And next one is a sys. System is very similar to operating systems, OS and sys, but difference here is operating system dependent on application specific system depend. If we say sys, then that is application dependent, which is a Python. If you say OS, then operating system dependent. Okay? What that means is that if I want to quit this first, and then I will do Python again, in order to, because I already imported it in the previous Python OS, so I restart from fresh memory. Here on Python, I want to import sys. So what is sys? Sys is program-dependent environment. When I import OS, now OS is operating system-dependent environment. You can get similar things. For example, os.getEnv path, then you can get all the path about the operating systems. You can do same thing in sys.path if you import to sys. So watch, if I do sys.path, then I can get the path expressions of this. As if I would do, for example, in another terminals, I run Python and I want to import OS. If you want to see the path expression in the OS, then you need to do get env path. Here, get env, and then you may be able to see path. I think uppercase path. Then you can get the path expressions. This is operating system's path expressions. This is the path expression that's available on the system. System is dependent on the application. So path here is a path available on your Python. When you have a path on this operating systems, then this is a path, all the path expressions available on your operating systems. That is the difference. Okay. Okay. So this is the end of the operating systems. You can have the different languages available for different the packages. OS package has, for example, this kind of methods available. Sys packages may have the field path so that you can access the content available in this path. Okay. That is operating systems. And the next one is Python. So I'm going to.
Professor, when I take Python in the terminal, it doesn't allow me to use Python. It brings up that I have to download it, but I already downloaded Python.
That was because your path expression does not understand yours. So, yeah. So what you need to do, you can set up the path like, look at here. This, I want you to look at this. Somewhere here, I have here the Python path already here, right? They're all Python paths. See, they're all Python paths up to this. They're all Python. Python 3.12, Python 3.9, Python 3.10. That's available on my OS. Therefore, I simply run it. If you want to, so you can add that path to your